Well, welcome back. Tonight our lesson is Unit 2, Lesson 3, and Unit 2, Lesson 4. Area of any parallelogram, page 51. So go ahead and jot that into your black notebook. This first page here wants you to cut out, and it kind of shows you the height of a parallelogram is a line segment that's perpendicular to the base. So down below here, you have these shapes to cut out, and then it wants you to place them together, and I'm just going to kind of show you this real quick here. It says, what figure did you form? When you place them together, you form a rectangle, and it says, do you think it will always happen when the height connects to base and the opposite side? Why or why not? Yes, because the slanted sides are parallel, so they will always fit together, and the cut sides give the new figure 4 right angles. Lots of vocabulary that we'll copy down for Lesson 3 and Lesson 4. But let's look at page 51 to start out with. It says Eric's solution. Here's how Eric found the area of a parallelogram with no vertices over the base. So in here you have this parallelogram, and then they're showing you that by extending the lines out you can make a rectangle, and you also have two triangles as well. But the formula says area of a rectangle minus the area of the two right triangles would give you the area of the parallelogram. So if you look at the whole area of the rectangle, that's where they end up with 11 by 2, which is 22. Area of the two right triangles, remember the formula for area of a triangle is 1/2 base times height. So they're looking at the 6 and the 2 here. 6 times 2 is 12. Half of that would be 6, but then there are two of them, so that's why they end up with the 12. And then it's telling you to subtract 12 from 22, which would give you the area of the parallelogram of 10. But if you look a little closer, it says, can you compute the area of the parallelogram above using the formula area equals base times height? And the answer to that is yes. If you look at the base right here of 1, 2, 3, 4, 5, the height of 2, there's your 10 centimeters squared, which is the same as what you found up here by finding the area of the rectangle and the area of the two right triangles subtracting. Number 2, it says find the area of the parallelogram, show your work. Again, using the formula, and let's go ahead and do number 2 in your notebook. Draw this shape, and here's this height that you're always trying to find, 90-degree angle, base times height, 1, 2, 3, 4, 5, 6, and it's each unit is 1 centimeter. So the base would be 6, the height would be 1, 2, 3, 4. So 6 times 4 is 24 centimeters squared. And then let's do number 3. Here you can see where I actually extended out, and again it's parallel, and then I made that 90-degree angle, so I got my height of 1, 2, 3. My base is still 1, 2, 3, 4. 4 times 3 would give you the 12 centimeters squared. So draw number 3, draw number 2, and solve. Alright, and this is just showing you again what the answers were. 6 times 4, 4 times 3. Height. By definition, height. The height of a triangle or quadrilateral, quadrilateral means 4, quad means 4 I should say, is the perpendicular distance from a base to a vertex that is not on the base. Finding this distance may require extending the base. So let's go ahead and copy these 2 examples down. You don't have to copy the definition, just write the word height and copy the example right here, and then also this example where you can make the height outside of the quadrilateral. And then it says parallelogram, which is a quadrilateral, quad meaning 4, in which both pairs of opposite sides are parallel and the opposite angles are congruent. So what does that mean? It means opposite sides, this side right here and that side are parallel, this side right here and that side are parallel, and then opposite angles, that's this angle inside and that angle inside, this angle and that angle. Go ahead and write down parallelogram, and then draw these 2 shapes right here. Perpendicular, another definition, line segments or rays are perpendicular if they form a right angle. A right angle has a measure that is equal to 90, and that's when you're finding area of like triangles and an area of parallelograms, finding that right angle for the height is needed. So draw this shape, and with this little box, and that box is telling us that it's a 90-degree angle, it's perpendicular. And then the base of a figure. For a triangle or parallelogram, a base is any side. For a trapezoid, a base is either of the parallel sides. For a prism, a base is one of the congruent parallel spaces. For a pyramid, the base is a face that does not touch the vertex of the pyramid. So I actually want you to copy down base of the figure, and then copy down the example for a triangle, base, base, base. For a parallelogram, base, 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 base. For a trapezoid, base and base. For a prism, opposite side, base, base. Do that as best you can as far as drawing. And then for this pyramid right here, you can see the base is the bottom, and it's the face that does not touch the vertex of the pyramid, and the vertex of the pyramid. Alright, so copy those down. Do the best you can with your drawings. Alright, so then we have our first puzzled penguin math problem here. It says, dear math students, today I made a design with the parallelogram shown at the right. Then I found the area of the parallelogram. Here is how I found my answer. Area equals base times height, which is correct. And he said that area equals 6 times 7, which equals 42. So the area of the parallelogram is 42 centimeters. Am I correct? If not, please correct my work and explain below. Your friend, the Puzzled Penguin. Well, you have the base of 6. The Puzzled Penguin has the base correct. Right here is actually the side of the parallelogram. It's not the height. You need to be using the 5 centimeters for the height. So if you use the 5 centimeters for the height, it would be 6 times 5, and the area would be 30, not 42. So in your response, 30 centimeters squared, but in your response, you should write, let's see if I can find it here, this for number 4, and I do want you to copy this down. Write the response to the Puzzle Penguin. The penguin used the length of the slanted side 7 instead of the height of the 5 centimeters to find the area. Alright, let's jump back then to number 5. It says, write a formula for finding the area of the parallelogram. The formula would be base times height. What measurement shown is not used for finding the area, and it's the side, which is S. And it says find a formula to find the perimeter of the parallelogram. Well, perimeter is walking around your shape, so you could do something as simple as B plus S plus B plus S. Or you have 2B plus 2S, which I think it shows you down here. 2S plus 2B, same thing. Number 8, going back, it says what measurement shown is not used for finding the perimeter. In this case, you wouldn't use the height. That's what it shows you there. So go ahead and make sure you have 5, 6, 7, and 8 done as well. And that was on page 52. Alright, let's move along. Another definition, rhombus. It's a parallelogram with all sides the same length. So it gets stretched out here, but this length is really the same and the same and the same. Doesn't really look like that in my picture. Alright, page 53, find the area of rhombuses. A rhombus is a parallelogram with all sides the same length. Place a check mark next to each rhombus, then find the perimeter and the area of each figure. Okay, so let's look at number 9 here. You have a rhombus. Opposite sides are all equal, so 6, 6, 6, and 6. Formula still base times height, so it's going to be A equals 6 times 5, which is 30 centimeters. Now, walking around the shape to find the perimeter, you'd have 6 plus 6 plus 6 plus 6. Or you have 4 times the sides, because you have 4 sides, so it would be 4 times 6, which would be 24 centimeters as well. And that looks like, so this would actually be a rhombus. 10 is not a rhombus if you look, because they're not the same. its parallelogram, 7 centimeters, 7 centimeters, 4, and 4. The area would still be base times height, so it would be 7 times 3, which is 21. Walking around it would be 7 plus 4 plus 7 plus 4, or you could take the side, 2 times the side plus 2 times, or 2 times the base plus 2 times, 2 times the 7 plus, no, that's not right, I'm sorry. Why am I drawing a blank? The 7 times 2, which would be 14, there we go, and the 4 times 2, which would be 8. They get the 22 centimeters. Number 11, it's also not a rhombus because you have 5 centimeters and 4 centimeters, but the area would still be area equals 4 times 3 is 12. Then walking around the shape, 4 plus 5 plus 4 plus 5, which would be 18 centimeters. All right, let's look at number 18. We'll skip over 15, 16, and 17. Number 18, it says a rhombus has a base of 11 centimeters and an area of 110 centimeters. So go ahead and write 18. And it says, what is the height of the rhombus? So we know the area is 110 centimeters, and we know the base is 11. So we have 11 centimeters times h. And in opposite of multiplication is division, so if you take 11 into 110, you end up with 10. So the height would have to be 10 centimeters. In number 19, what is the area of the rhombus at the right? Explain how you computed the area. Well, if you look over on the right, there are actually 4 triangles there. Here, 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 and here. And the formula for triangles is area of triangles is 1/2 base times height. So if you look at the 3 and the 4, so it would be 1/2 3 times 4, which would be 12, because this would be an actual side. And half of that would be 6, and then remember we have 4 of them, so if you took 6 times 4, you end up with 24 centimeters squared. So go ahead and copy number 19 down as well. All right. I think this was the page we were just working on. Yep, it was. So that you can see that number 9 was checked, but 10 and 11 were not. All right, let's just jump over that. Let's look at number 20 here. June is designing a pattern for a rug. She will use a rhombi with triangles in between. Each rhombus will have 10 inches for sides and 9 inches for height. What is the area for? So it's again, area equals base times height. Has a base of 10 and a height of 9. And there's 4 of them. So it's going to be 10 times 9, which is 90 inches squared, times 4, which would give you the 360 inches squared. Yep, that's right. So go ahead and copy that down as well. And then let's look at, yeah, there's that for number 20. 360 inches squared. All right, jumping on to lesson 4, area of any triangle. And now it has you cutting out some, but we're just going to take a look at it. Acute triangles and obtuse triangles. What you have here is an acute triangle below exactly the same. Cut them out and rotate one so that you can place side labels A together. What shape do you form? Do the same with sides labeled B and C. Now to be an acute triangle, all angles inside the triangle need to be less than 90 degrees for a total of 180. Obtuse, one angle in the triangle has to be greater than 90 degrees. So, oops, sorry about that. Okay, and if you put 2 of them together, you end up with a parallelogram. And then down below here, obtuse triangles below exactly the same, cut them out. So here's where you have this one inside there that is greater than 90 degrees. So these other 2 This one would be greater than 90. These other two would be less than 90, but the total would equal 180 degrees. And it would form a parallelogram as well. Alright, so this page here says draw parallelograms and triangles. I'm actually going to get rid of this stuff here because it's a little bit confusing. There we go. It says answer the following question about triangle ABC. So it says measure and label side AC of the triangle in centimeters. So A, the C is 7 centimeters. From B to there, which would be the height, would be 4 centimeters. And it says measure and label the height, which we did. And go ahead and draw this as well. What is the area of the triangle? So now we're just talking the area of the triangle from A to B to C. So that's where I had that. A, B, C. Area equals base times height. Half of base times height, excuse me. Area equals half base times the height. So it would be 7 times 4 would be 28, and half of that would be 14. That's where they end up with 14 centimeters squared. And then it says use your ruler to draw a line segment through B that is parallel to AC. So right here, parallel to AC, never going to intersect. And it says draw a line segment through C that is parallel to AD. So right here and right there. And then it says label as D, which is what they did. Go ahead and do that as well. And then it talks about that a related parallelogram has the same base and height as a related triangle or rectangle. What is the area of the related parallelogram? So the whole thing, the triangle is 14, but the whole parallelogram would be base times height, which would be 28 centimeters. And then it has you doing the same thing down here for number 7, but we won't do that. Number 8, let's take a look at that. Get rid of that for a second. It says measure and label side AD, so they're saying from A to D is 6 centimeters. Measure and label the height, they're saying from B to there is 3 centimeters. What is the area of the parallelogram? So that's going to be this length, base times height, 3 times 6 is 18 centimeters squared. And then it says joints points B and D, so they're saying B to D, they draw a line from B to D. Name the 2 triangles. Well, then you have triangle ABD, ABD, and triangle DBC, triangle DBC. And then to find the area of ABD, it would be 1/2 the base times the height, so it would be 6 times 3, and half of that would be 9. So 9 centimeters squared would be the area of each triangle, and that would be the same for CBD as well. And then it says, what kind of triangle did you make in exercise 11? It's again looking at the insides. So it's looking at the insides, and those are all acute angles. So they are acute triangles. Okay, and then that's having you do the exact same thing with 14 here. Divide parallelogram ABCD into 2 obtuse triangles. So now they're making obtuse triangles right here and right there. The formula is still half a base times height, so the base is still 6, the height is still 3. 3 times 6 is 18. Half of that would be 9 centimeters squared. Okay. Number 16. Draw 2 different diagonals for parallelograms, E, F, G, H. Name the triangles, measure them, find the area of each. So they're saying draw one from H to F, draw one from E to G. And then it's saying the area of the triangle E to FG and HFG. So they're saying from here to here was 5 centimeters. And then the height, if we put that in, was 2, because remember the formula is 1/2 base times height. and they said that the total area was 5 centimeters, so the base had to be 5, the height had to be 2, which would give you the 10, and then half of that would give you the 5. If that makes sense. Alright, let's jump ahead here real quick to these definitions. Acute triangle, a triangle with 3 acute angles. An acute angle has a measure that is greater than 90, but a 0 and less than 90. So go ahead and jot that definition down. Acute triangle, greater than 0 and less than 90, and then draw one. And then the same for obtuse. Greater than 90 and less than 180, and then copy down an example of that one as well. And then there's a couple more definitions here. Let me just maybe jump to them right away. Vertex is what I'm looking for. Right here. This is a. Oops, sorry about that. Let me get back out of that. Just definition for vertex: a point common to 2 sides of an angle or polygon, or 3 edges of a solid figure, the point of a pyramid. So go ahead and write down vertex, and then these 3 examples here, draw them the best you can, and then label that vertex. There's a vertex and a vertex on that pyramid there as well. Alright, I'm going to jump back to where we left off. Let's see. I think we did those. Let's go ahead and jump to page 55, and it says answer the following questions about triangles A, B, C. So they're talking about A, B, C. It says measure and label sides AC of the triangle in centimeters. So it looks like I had jotted down here that it must have been, that's a 7 there. So A to C is 7, and then from B to here, which would be your height, would be 4. What is the area of the triangle? So it would be 1/2 of 7 times 4, which would be 28, divided by 2, which would be 14 centimeters. And then it says use your ruler to draw a line segment through B that is parallel to AC. So through B, that is parallel, so right here, all the way through, and then, which is parallel to AC. And then, like before, they labeled it D. Alright, so what you've made there is a related parallelogram, a parallelogram with the same base and height as a related rectangle or triangle. So related rectangle and related parallelogram. So here's your rectangle, and then it's related parallelogram, same area, triangle and related parallelogram. So you have your triangle. If you make that parallel line on the opposite side here and there, it is related to a parallelogram. That's all I'm trying to get you to understand there. Let's just jump over a few of these. I guess we can look, let's go back to this one. Actually, let's go right here because it has the answers. You don't have to copy this down, but let's just look at 8 here. Measure and label side AD. So they're saying from A to D is 6 centimeters. Measure and label the height. So right here is 3 centimeters. So it says, what is the area of the parallelogram? Be 6 times 3. Parallelogram ABCD, ABCD. 18 centimeters squared then. And then it says join points B and D. So B to D, which you would make a triangle then. Name the 2 triangles. You have a triangle ABD, and you'd have a triangle DBC. And then the letter in the middle, the B and ABD and DBC, the B would be the vertex. And that's why I had you copy that definition down before. So B is the vertex for both of those triangles. If the area of the whole parallelogram is 6 times 3, which is 18, half of that for the triangle would be 6 times 3 divided by 2, which would be 9 centimeters squared. What kind of triangles did you make in exercise 11? Again, looking at the insides. Those are all acute, so it would be acute triangles. And then that's having you do the exact same thing for 13, 14, 15, and 16. Skipping over this, I think we covered pretty much all we need to worry about. We will definitely work on this in class. The puzzle penguin, I will skip over that. And tomorrow in class, you'll work on 2.3 and 2.4. That concludes Unit 2, Lesson 3, and Unit 2, Lesson 4.